All right, so we're going to be doing an example of our function and creating the critical points, intervals of increase, decrease, relative extrema, and possible maxes and mins. And so everything's related to this function. So the first thing you want to do is take your calculator and input it into the calculator as your y value. Since we're asking, is this function the one that's increasing, decreasing, so on and so on. The next thing to do is to find your critical points. And so that is when our derivative is equal to 0 or d and e. So we're going to be doing those two steps. Number one, find our derivative. So that would be negative 4x cubed plus 24x squared. And then we're going to be setting it equal to 0 since this one cannot equal d and e because there's no denominator here. So we have negative 4x cubed, it's also a polynomial, plus 24x squared. So if we factor out that negative 4x squared, we end up with x minus 6. So negative 4x squared equals 0. This would give us x equals 0. And x minus 6 equals 0 would give us x equals 6. So those are our two critical numbers. So now that we have our calculator, we know it's going to occur at 0 and 6. We want to go to our window and give something a little bit before 0. So negative 3 is a good enough number. Something a little bit more than 6, 10 is good enough, but we don't want to overshoot it. And now if you hit zoom and 0, it's going to fit that domain that we just inputted into our calculator and give us what we need. All right, so you can see we have a little bit of a change here and a change here. Those are our critical numbers. So if I plug in trace and 0, looks good. Trace and 6, trace and 6. You can see it didn't show up. That's perfect. That means we're at the top there of this. If you really want to see it, you can go to your window, change your Y max to 900 so we get a little more height. Hit graph. And now you can see there's a little bit of a gap there. So now when I hit trace and 6, it does blink right at the max. And that's what we're looking for. Remember, our critical numbers are when our derivative is 0. So you can see we're increasing here, and then we're decreasing. That's our change. So everything looks perfect. So now intervals of increase and decrease. And so how we do this is I'll show you two different ways. One algebraically, and one with the calculator. You put 0 and 6 on here. And so we know this is when our f prime of x is equal to 0. So if it's not 0, the only other options are positive and negative. And so all we have to do is test one number in here. So something to the left, I like 100. Something to the right, I like 100. I like big numbers because they tell us very quickly if it's right. And then something in the middle is 1. See, if you look at our graph that we have, it's doing this. And so this right here is our f prime of x equals 0. And so you can see our graph is increasing. And then it's decreasing. So when it's 0, it's 0. But any part in between there, it's either always decreasing or always increasing because you cannot go from a negative to a positive without going through a 0 or a d and e. So since we are positive here, we have to go through a 0 to get to a negative. And so it must be always decreasing or always increasing in between our critical numbers. So if we plug in f prime into our function and we want to plug this into our derivative, I like to use our actual function itself. So if we have negative 4, you're going to be plugging the negative 100 in here with a square, and then 100 minus 6. And so you can see if we use large numbers, it's very obvious. Now, with the square, it's squaring anything is always going to be positive. So really, when we look at this problem, what we're dealing with is this. It's a negative 4 times a positive times an x minus 6. So you don't actually have to plug it in because we're just looking for the sign. So this would be a negative times a positive, and then 100 minus 6 would be a positive. So what is a negative times a positive times a positive? That would come out to be negative. Okay, now let's plug this in correctly. This is a negative 100 minus 6. So this is negative, positive, and negative. And these mistakes will happen, and that's what's nice about having the calculator. You can see that we are increasing here from negative infinity to 0. And so these two have to come out positive. So we already know by our calculator that these are positive and these are negative. We just have to show them algebraically as well. So negative times a positive times a negative, that is equal to positive. And then we do the same thing. I'm going to move the f to the negative f prime of 1 over. And so this would be negative 4 times a positive times 1 minus 6. And so this again is a negative times a positive times a negative, and that becomes positive. So it checks. And then the 100, we already did that one in the beginning because I forgot the sign. So this would be negative times a positive, and then 100 minus 6. So that's negative, positive, positive. And so a negative times a positive is a negative. So we know it's increasing from negative infinity to 6. And you may be thinking about, oh, well, what about 0? Well, let's look at 0. So if we take this and we go from here, you see how the line is always increasing. Did our dot ever go down? No. The dot is always increasing. All the way up from here, all the way up. So this is an increasing value. Now it's decreasing. So from negative infinity to 6, it's increasing. And from 6 to infinity, it's decreasing. So the reason we don't include the 0, you may be thinking, oh, well, the slope was 0 though. But it doesn't matter. See, our dot going to this point, even though the slope is 0, right before it, you can see it's 3.99776, and then it became 400, and then it becomes 400.095. So going from this point to that point, which is our critical number, and from the critical number to the next point, it was still an increase. It didn't go down. So this makes this an entire increase, even though the slope of that derivative here is 0. So only when we get positive to negative do we get a change from increase to decrease, for now with polynomials. I will give you a bunch of examples of other situations. Okay, so you have to also look at the graph itself to determine whether it's a full increase or not. So give the location of local extrema and classify as a relative maximum or a relative minimum. So in order for it to be a maximum, we need to have this situation. And in order for it to be a minimum, we need to have this situation for our polynomials. And so for polynomials, that would mean that we have an increase and then we have a decrease. And for a minimum, we would have a decrease and then an increase. So whenever you see it go from positive to negative through that critical number, or negative to a positive through that critical number, then we know that it is a minimum and a maximum. So this is a max. That's what we have here. We're going from positive to negative. And so I like to mark it as positive, negative, which makes that a max. So we do have a maximum at 6. So now how do you find that value? Well, we've already got it graphed. So all we had to do is hit trace 6. So if you hit trace and 6 and hit enter, it says it's 832 is our maximum. That's it right there. So 832. So we have a relative maximum of 832 at 6. And there is no negative to positive going on here, so there is none. There is no relative minimum here. All right, so now absolute max and min. If you look, that is an absolute max because it increases to it and decreases. So in order to get an absolute max, we need to have that increase all the way up and decrease all the way down and no back up. It's not going to come back up again, not going to come back down again. And the way we can tell it's not going to do that, so if you expand the graph farther out, is there is no more critical numbers. So if our graph was to come back up like this, what would it have to have? It would have to have another critical number, and there isn't one. So if it doesn't have another critical number, it's not coming back up. It's done. It's finished its thing. So when this is a max, it's not only a relative max, it is a actual max. And we don't even have a relative min, and we don't have endpoints, so there is none. And so there you go. There's all the questions. And you notice every single question revolves around your critical numbers, and that's why they're called critical numbers. Now, this one asks us to find critical points. So what is the difference between that? And I wanted to do that at the very end. Critical points So our critical numbers are x equals 0 and x equals 6. Our critical points are the actual points. So if you go into your calculator and you hit trace, and so we already know 6 is 832, so we would have 6 comma 832. Now if you do the same thing with the 0, it's 0, 400. Those are your critical points. So critical numbers are the x equals 0 and x equals 6. Critical points are the 0, 400 and 6, 832. And those are what are very important for all of our questions. All right, thank you.